Welcome to part 2 of the ReGenX generator video demonstration. Right now we have our ReGenX generator idling on no load at 3,450 RPM. And what we're going to do in this demonstration is we are going to use the conventional generator coil in the prototype to demonstrate generator armature reaction, and then generator armature reaction, aka regenerative braking in an EV, and then we're going to demonstrate regenerative acceleration, and we're going to point out the load current delay and explain where the regenerative acceleration phenomenon comes from, and it should be self-explanatory. Okay, so right now we have our generator is idling. The system is at equilibrium, which means that the net power in the drive shaft going to the generator is zero. The system, the power in the drive shaft is the torque times the speed, and when the system is at equilibrium, the net torque is zero, and the net power in the drive shaft is also zero. So when we place the generator on load, the prime mover will respond by delivering the prime mover will respond by consuming additional power and delivering additional mechanical power into the drive shaft of the generator. When the ReGenX generator is placed on load, the prime mover will respond by delivering less mechanical power. In fact, less mechanical power than is required at idle. So I'll put the conventional generator coil on load right now. Okay, so I've placed the conventional generator coil on load. We can see that the load current is 0.88 amps. There we go. Okay, I'm going to put it on to no load again. So on no load at equilibrium, our system speed is 3,458 RPM. The input current, or the input power to the prime mover, is 144 watts. When we place the conventional coil on load and we deliver approximately 10 watts to the load, this is here. When we deliver approximately 10 watts to the load, The prime mover responds by consuming an additional almost an additional 20 watts. And the system decelerates. I'm going to put it on to no load again, and then I'll put it on load. So here we are at no load again, steady state speed, equilibrium. Prime mover is delivering 145 watts. The prime mover is consuming 145 watts, and at equilibrium, the net power in the drive shaft is 0. And when placed on load, the prime mover responds, the counter torque produced by the generator decelerates the system. The prime mover responds by consuming more power. We're delivering 0.87 amps to the load. And we can see the load current sine wave for the conventional coil on the oscilloscope. So now I'm going to put the ReGenX generator coil on load. So now the ReGenX generator coil is on load. We are in regenerative acceleration mode. We are delivering 0.92 amps to the load. Our system speed is 3,464 RPM, 64, and our input to our prime mover is 140 watts. The input to the prime mover is consuming less power and delivering less mechanical power in the drive shaft than when the system is on no load. So I'm going to put it back into regenerative braking mode again. And you can see in green, the load current sine wave for the conventional coil, and then the load current sine wave for the ReGenX coil, which is delayed by approximately 50 degrees. So back into regenerative braking mode. So now, if this was in an electric vehicle, the vehicle would be in regenerative braking mode and delivering power to the batteries and decelerating the vehicle. And now I'm going to place the generator into regenerative acceleration mode. Now the generator in the electric vehicle is in regenerative acceleration mode. The speed of the EV has increased. The output current, the recharge current, the regenerative acceleration current going to the EV's batteries has increased, and the prime mover, or the EV's motor, is using less power than when on no load. And I'm going to place, I'm going to shift the ReGenX generator coil's load current to basically 90 degrees. So now we have increased the load current delay in the ReGenX generator coil to 90 degrees. The input to the prime mover has gone down even more. The load current has increased slightly and the speed has also increased slightly. So the ReGenX generator coil's load current delay needs to be minimally 45 to 50 degrees to induce regenerative acceleration, but it can also go to 90 degrees as well if that's desired. And that's the end of part 2. ReGenX motor is coming up next.